B is going to be growth or decay factor, which I'm going to talk about here in a tiny second. And especially, I should maybe have written this. If you're working with a word problem, the X generally tends to represent time. If we just have like a generic equation that we're working with, it wouldn't necessarily represent something. But if you do have a word problem, A is the initial amount, B is the growth or decay factor, and then X is time. Okay, now, in this, it says A cannot be equal to 0. Now, this is what this means, the B value. So whatever I'm taking to the exponent, all right, whatever has the exponent, B is greater than 0, that means the B value has to be a positive number. If you're greater than 0, it just means you have to be positive. And so you're not going to have any negative B values. That's not exponential. So there's two things that can happen. If that B value is greater than 1, then we're going to have exponential growth. And you can't be negative. So if the B value is between 0 and 1, so like maybe you have 1/2 or like, I don't know, 0.65. It could be a decimal, it could be a fraction, but if it's some number between 0 and 1, then you're going to have exponential decay. Now, if you have growth, what they call the growth factor and the decay factor is that B value in that little formula. B is going to be, it says 1 plus R. The letter R represents the rate of increase or the rate of decrease, which we'll talk about as we get to these questions. So if you have growth, it's 1 plus the rate. If you have decay, it's 1 minus the rate to get these values. And we're going to start off with some equations that are already kind of set up, and we're just going to say whether they're growth or decay. And then I'm going to see if you guys can tell me the percent of growth or decay. Okay, so we're not going to graph this. Determine whether this is growth or decay, and I should have said this to you. Neither would happen in the situation where the A value is negative. I don't think that I have that on any of the questions today, but if the A value is negative, whatever your equation starts with after the equal sign, that's neither growth or decay. We'll deal with that a little bit more tomorrow when we have some graphs that we're going to work on. But these are in the form, right? Y equals AB to the X. So whether it's growth or decay totally depends on whatever's being taken to the exponent in each of these equations. I just have a little set of parentheses around it. So if we're looking at the B values 0.78, right? Would you tell me that is growth or decay? Decay. It's smaller than 1. This is decay. Okay, now this is tricky. Does anybody know how to tell the percentage of decay? Okay, so then is it 78? We could change it to a percentage by doing that. So that be, does that represent 78% decay? This is really tricky. It's 20. Whoever just said 22%. Yes. Okay, so the B value is, if you have decay, 1 minus the rate. So if you could actually set this up. If you did 0.78, it'd be 1 minus the rate. If you want to just figure out, the way I do it, I usually just figure out, okay, what would that need to be to add up to 1 or add up to 100? Like, think of that as 78%. If it's decay, it's going the other direction. So if I subtracted 1 here, this would be negative 0.22 equals my negative rate. So 0.22 would be the rate. The negatives on either side would cancel out. And then, just like Kai said, you're going to just multiply that by 100 to get the percentage. So this would be 22% for the decay. You don't have to write out a bunch of work for that, but you just got to figure out, like, how much am I, think about, like, if you got a 78 on the test, right? How much did you take away? I'm taking away 22%, so that would be the decay. All right, so like this one, my B value is 0.5. Does anybody, is that growth or decay? Decay again, right? Okay. Does anybody know what the percentage would be there? 50, exactly. So this is 50% decay. It's just whatever that would add up to. Think about that. That'd be like a 50%, whatever you would add up to get 100. Okay, now this last guy, this is bigger than 1, so this is going to be growth. I have 1.3, my B value here. Okay, now this is tricky. How much growth would that represent? 30%. So like think about that, like if I multiplied that by 100, that'd be 130. So 100 would be, here's my playing like maximum. It's what's over 100 in that case. So this would be 30%. If you like, what the heck are you talking about? In those two little formulas up there, if you have growth, B is 1 plus the rate. So if I have 1.3 here is 1 plus the rate. If I subtracted 1 real quick, I'd get 0.3 as my rate of increase. And then again, you could just multiply that by 100, just scooch the decimal place over 2 spots. That's where you get the 30%. Does anybody have the question? Okay, so for B here, if this is 0.5, so if it's between 0 and 1, so it'd be a half. If it's between 0 and 1, it's decay. So you could do that little equation here too. So 0.5 would be 1 minus the rate there. If you subtracted 1 from that, you'd get negative 0.5 is negative whatever your rate is. The negatives cancel out on both sides, so 0.5 would be the rate, and just multiply that by 100, it scooches the decimal place over, so it's 50%. You just got to decide if it's growth or decay based on whether that number is bigger than 1 or between 0 and 1. Really good question. Anybody else have any question? Okay, now the rest of example 2 here is a little different format. We're going to actually write an exponential function. So I just give you the general form here. All right, and we're going to do this with points, and this is a little tricky, and I've got some tricky fractions here to work with, but I promise we'll have nice values when we actually get through this process. So what you want to do here, and just do this for me, you're going to write down 2 equations here, but you want to pick the point, whichever point they give you that has the bigger x value. Just, I promise that'll make the problem easier to do. So they're going to give you 2 points. We're going to write an exponential function from this. In that form, y equals ab to the x. Whichever one has the bigger x value, start with that point. So for my little example here, that's the 4 and the 1/3. That's a bigger x value. Okay, all you're going to do, we're going to write 2 equations. It's going to be like a little system. And just in place of the x and y, in that general form of the exponential, we're going to actually write the points. So for the point I want to start with, the bigger x value, I'm going to do y equals ab to the x. We're going to figure out a and b. So y in that point is 1/3 equals ab, and then to the x, that's the exponent. So I would write 1/3 equals ab to the 4th. Okay, now I'm just going to do the same thing, but with the other point. So the y value there, 3, equals ab squared. Now I know this is going to be kind of weird. So this is not like a system that you guys are used to where you like add the bottom line to the top line or whatever. Whenever you're working with an exponential equation though, you can use this. What you want to do is you want to divide the bottom or the top line by the bottom line. Now the reason I'm going to do that, if you set up the format where you plug in the x and y, is going to be the y's here, the x is the exponent. If you divide the bottom line by the top line, the a value, you would just have a divided by a, so it cancels out. So that's why I'm going to do this. Okay, now you can do this by hand. I'm going to grab my calculator because I'm going to be lazy today. So I'm going to take 1/3, I'm going to divide it by what's underneath it, which is 3. I'm going to do my math, enter real quick, and this would be 1/9. Okay, now I'm going to use exponent properties here. If I take b to the 4th divided by b squared, what would we get? B squared. Okay, now remember, my b value is not allowed to be negative. All I'm going to do to solve this is I'm going to take a square root, but when I do that, we're not going to put a plus and minus because by definition, if you're working with an exponential, the b value cannot be negative. So we're not going to put a plus and minus. What's the square root of 1? What's the square root of 9? 1/3 is going to be my b value. Okay, now all you have to do to get the a value is plug that back in, and you can plug it back in just like a system to either one of these equations. but I don't want to deal with the fraction, so I'm going to plug it in right here. So I'm just going to do 3 equals a. Now I know the b value is 1/3 squared. All right, so this would be a times 1/9, and I'm just going to divide both sides by 1/9 to get the a value. So I'm just going to take my numeric calculator. I'm going to take 3 divided by, I'm going to put 1/9 in parentheses, and it's actually like the same as multiplying by 9, so it's going to be 27 for your a value. Now, to write the actual equation for my answer, we're just going to have a y and an x in our actual answer. So I'm going to write y equals 27. B value is 1/3 to the x. Now, don't multiply these numbers together. You're going to take 1/3 to the exponent. That has to go in your order of operations before multiplication. So don't do anything else there. Don't multiply those numbers together. That's like the most common mistake people will do. Is anybody having a question? The ones on the notes are a little bit harder than the ones on the homework. I tried to do harder problems so we could do them together. Okay, I'm going to do this one more time. All right, pick whichever point they give you, whichever x value is bigger. So I have -2 and 2, so I'm going to start with the 2. All right, we're going to do 20 is ab squared. The y goes in for y, and that ab to the x, and the x goes in for x. The other point, I've got 5/4 as my y value, and I have ab to the -2. All right, now, whenever you do a system like this, you're going to divide, because when you do that, you always would have a divided by a, so it just cancels out, or just becomes 1. So we're going to find the b value first. I'm just grabbing my calculator. I'm going to do 20 divided by 5/4, and that's 16. Okay, now, tricky question. If I do b squared divided by b to the -2, what would that give me? Exactly. This would come back up here, so I'd add 2 to that, so this would be b to the 4th. Now, again, I know I'm going to have a 4th root here, and I should put a plus or minus, but because we're working with an exponential, the b value is not allowed to be negative. But I do just want to take 4th root of both sides. What is the 4th root of 16? 2. So your b value here is just 2. Okay, once you're there, all right, and pick something easy. Don't mess around with the fraction and the negative exponent. Plug it into the first equation. That's way easier. So I'm going to do 20 equals a. I still don't know. That's what I'm going to try and figure out. I know b now is 2, and then that's squared. So I'm just plugging it into that first equation. So I get 20 equals 2 squared is just 4, so that'd be 4 times a. And so if I divide both sides by 4, that's going to give me my a value. And then we're just going to write our answer. So it'd be y equals 5 times 2 to the x. And again, don't multiply the 5 and the 2. Only 2 is going to be taken to the power, and then we'll multiply by 5 after the fact. Okay, is anybody having a question? All right, now I'm literally giving you the same problem at the bottom of the page here, but it's given to you in a different format. So at the very bottom of the page here, I just gave you a graph instead of me saying here's 2 points. So you actually have a ton of different points that they have marked on that graph. Anybody have a preference what point they might pick? For sure. Okay, if you have a graph, or if you have the point that has a 0 in it, please pick that point. Now, you can pick any other point you want, so we'll use the 0, 3, and honestly, it doesn't matter. If you want, I'll just pick the 1, 12, that's right, but you can pick any point, but if you have a point that has a 0 in it, please pick that, and you'll see why in 2 seconds when I set this up. Okay, I'm going to start with the bigger x value, so that would be this point. So I'm going to write 12 equals ab to the 1st. Then the other value of x is 0, so that's a little smaller, so I'm going to write 3 equals ab to the 0. What is anything to the 0 power? 1. So if I have this right now, I have my a value. if you can get an exponent, or sorry, a variable, or I'm going to try a point that has 0 as the x coordinate, you can have your a value right away. So I don't even have to do a system here. I can just get the a value because this becomes 1. Now, all you're going to do, just plug that back in, we'll get our b value, just use the other equation. So I'm going to do 12. I know a is 3 from that other equation, and then b to the first would just be b. So this is 12 equals 3b. We'll divide both sides by 3 and we're done. So b is going to be 4 there. So my actual equation for that graph, same concept we were just doing, we just had more points to pick from. This would be a, which is 3, times b, which is 4, to the x. If you get a point that has a 0 in it, that makes the problem so much easier to do. And don't flip the page and be like, oh, word problems. They're easy, okay? Just relax. Okay. Just relax. Okay, I promise these are not hard. All right, so we're going to do, all right. We're going to do this format. Okay, so y equals ab to the x. The same thing I gave you on the front. We're just going to do some word problems. Okay, says a house is purchased at $155K. So my initial amount is going to be my a value, which is this $155,000. You don't have to put the money sign in front of it. I don't know why I did that. Okay, now, does appreciate mean it's increasing or decreasing? Increasing. Okay, most generally, if you're talking about house prices or car prices actually generally go down, but they go up. So when you do the b value here, it's increasing. So this would be 1 plus the rate. Do you guys, most of these questions are going to give you the rate as a percentage. So it says it's increasing at 3.5%. They do that to make it seem like it's more than it is. Do you know how to change that 3.5% to a rate? So instead of being a percentage as a decimal, you're close. Okay, if you're not sure. All right, so it's a percentage, right? Percentage is out of 100. You just take 3.5 divide by 100. You're actually going to scooch the decimal 2 spaces. So this would be 0.035 as the rate. All right, so for this problem, what the 1 is, the 1 accounts for what you've already paid. You've already paid the $155,000, and then add that 0.035. That'll just increase and then add on to it to give you the rate. So here's the general formula for this. We paid $155,000. Now, if I actually add 1 to 0.035, we'll have 1.035. And then to the x, that would be a general form for how much this house is worth after we don't know how many x would be years. All right, so there's a general formula for it. Okay, now, the question then says, use your model, that's what we just wrote, to determine the house is worth, what the house is worth in 10 years. Okay, so literally all I have to do for that is grab my calculator, because these are usually not the nicest numbers to work with, and we're going to plug in 10 for x. That's literally it. Okay, so I'm going to do 155,000 times 1.035, and then just do that to the 10th power. And then a lot of these questions will talk about money, so we're going to go 2 decimal places if we're talking about money. So it'd be like how much change you would get. So in 10 years, this house is now worth $218,642, and then I would round that to 81 cents. And that's all you have to do. You just got to pick the information out of the problem. It's not terrible once you set it up. Okay, now, most of the time, if you're talking about a vehicle or a boat or something like that, those go down in value most of the time. All right, so this says a new truck sells for $29,000. I probably need to update some of these examples because that's probably dirt cheap. So the initial value of the truck is going to be what we're going to plug in for A in that general form. Now it depreciates. So depreciate means it loses 12% of its value. All right, so we're going to do 1 minus the rate. But let me just ask you, let's say we had a test and it was 100%. If you took 12% away, it went down 12%, what would your grade be? 88. Okay, so this is going to be 88 in terms of what we're going to put in here. It's going to hold 88% of its value. If you want to put that into this little formula, it'd be 0.12, but you're going to get 0.88. That's going to be the depreciation. You hold 88% of your value. So my general model here, we'd have the 29,000, and then it'd be 0.88 to the X to figure out what it would be after X number of years. So 12% means it's going to hold 88% of its value, but it's still going to decrease. So this should be less than 29,000 when we plug it in. Okay, it says what's the value of the truck after 7 years? So we're just going to take our model and replace X with a 7. That's all I'm doing, just 29,000. And then 0.88 to the 7th power. And again, we're talking about money, so I'm going to round to 2 decimal places. So this would be $11,851.59. It's not bad to do once you set it up, but you probably do want a calculator for these questions today because it's a little bit annoying to work with some of these numbers. Okay, now this last one's a little tricky. So this says an investment is worth, so now I know what it's worth after 8 years. 56,578. That's not the A value. This would be like Y in the problem. 8 years would be the time. That would be the X. Now, this straight up says growth factor. So if you guys remember on the front side, the B value is 1 plus the rate or 1 minus the rate. That's the growth factor or the decay factor. So they are straight up telling you that is the B value. You don't have a percentage here. You don't have to add or subtract anything. They're just straight up telling you the B value. It says find the original value invested, and then we're going to find the percentage increase the investment earns every year. All right, so here's your investment after 8 years is $56,578. I don't know the initial investment. That's actually what we're figuring out here. So that would be just the A. They give us the growth factor, 1.15, and they give us the time. So I also know the exponent, which is 8. Okay, before I find the original investment, can anybody tell from looking at that what percentage increase that the investment is earning every year? Can you tell from looking at that B value? If I have 1.15, what percentage am I earning every year? 15. It's whatever it is over 1. So if it's over 1, this is going to be 15%. So it's earning 15% every year. Now, how would you guys actually, because my goal here is to find the initial investment. How would you solve that equation? You got to divide. Yep. All right, now you're just going to take this and divide by 1.15 to the 8th power. It's just some number. I don't know what it is off the top of my head, but we're just going to take and divide by that. You can do it all in one step. So I'm going to take the 56,578, divide by 1.15 to the 8th power, and just hit equals. Now, they're getting 15% interest. So what they gave me, what I started out with should be smaller than that. So that makes sense. So this is going to be my original investment, what I just have on my calculator screen here. And then it's increasing 15% every year, which is super good interest rate. So we're going to do money here. So we've got $18,495.45 would have been the original investment. And then in 8 years, that's a lot of an increase. Does anybody have a question? Okay, I got one more. Now this is just kind of like a modification, the half-life of your general exponential. So here's what this looks like. Y equals, and I'm going to write A. Whenever you work with a half-life problem, you're going to take half the substance away. What is usually some kind of a weird element with a weird name, as you're going to see in these problems. But you're going to take half of it away. So the B value, no matter what, if you're working with a half-life problem, you don't have to figure it out. It's going to decay 50%, so it's going to be 0.5 if you're working with a half-life problem. Okay, now the other thing that's just slightly different is the exponent. So the exponent is a fraction. And it's not hard to do, but it's X would be the time over the half-life. And we're going to get into this. So it's just a little bit of a modification of the general exponential. The b value is always a half for a half-life, and then the exponent's just a little bit different. It's x over the half-life. Okay, so some of these are really weird words, but they're actually legitimate substances. So this says a hospital prepares 50 milligrams supply. So 50 milligram supply of, I can't even pronounce that, technetium, I think, 99, which has a half-life of 6 hours. Okay, so I start with 50 milligrams, right? My half-life, so I'm going to put 0.5 is going to be the decay rate. And then it tells you the half-life is 6 hours. So the exponent here would be x over 6. Now, the time for x has to be in the same units as the half-life when you do these problems. That's not going to be an issue here. But then we're going to talk about how much of the substance would remain after each of these. Okay, so how much would remain after 6 hours? Right? So my exponent, if I plug that in, would be 6 over 6. See if this makes sense to you. So that would just be to the first power, right? 6 over 6 would be the first power. So it would be 50 times 0.5. So after 6 hours, 25 milligrams would be left. Does that make sense? Because you got one half-life there is what's going on. So that's why that exponent's a little bit trickier. So it takes 6 hours for this to cut in half. Does anybody know what it would be after 12 hours? 12 point, it would just be another half-life. So this would be 50, you don't have to write this out, 0.5, this would be 12 over 6, but that exponent is really 2, so it would be 2 half-lives, so I'm cutting it in half twice. So this would be 12.5 milligrams. Now 15, 6 doesn't go into 15, so this will probably be a weird decimal, but we're going to do 50 times 0.5 in 15 hours. This would be 15 over 6. You don't have to reduce the fraction or anything like that. Just type it in your calculator. So after 15 hours, I'm going to do 15 divided by 6 in my exponent. This, I'm going to go, this says round to the nearest thousandth in the direction, so that's 3 decimal places. So I'm going to go 839 there, milligrams. And depending on the number of hours, these can be some really weird numbers, so don't think you're doing anything wrong. Does anybody have a question? Okay, I want to do one more with this, but this one's tricky. So the time for x has to be in the same units as the half-life. So for this guy right here, this says I-123 used for thyroid scans. The half-life is in 13.2 hours. Write an exponential decay function if you have a 360 milligram sample, and then how much is left after 3 days. All right, so just in general, you got 360, that's your initial amount. If we're doing a half-life, my b value is going to be a half. Now, my time is over the half-life for my exponent, which is in hours. If those units don't match, we want to find 3 days. They have to be the same units. All right, so I need to figure out 3 days would be how many hours, because I need the units to be the same for this type of a question. So they have to be the same time. How would I figure out how many hours are in 3 days? What do you think? You can add, yep, either way. If you want to just 24 3 times, or you could do 3 times 24 because there's 24 hours in a day. Should be 72. So just use, this is going to be what you want to plug in for x. All right. So to actually answer the question, we're going to do 360. Just grab your calculator, 0.5, and you just have to make sure the units are the same for the x value and the half-life. So they have to be the same units. The previous question, I didn't have to worry about that because it was in the same units. And then I'm just doing 0.5 to the 72 divided by 13.2. If you guys are working with a scientific calculator, it would not like it if you use the fraction key and you had a decimal. So if you're using a scientific, if you want to just do like parentheses, do like 72, actually use your division key, divide by that 13.2, it'll work. It just won't like it if you try to use the fraction key with a decimal. So 8.2 Ooh, if I can round this to 3 decimal places, this would actually be 8.21, because that 5 would round that 9 up, and then the 9 would round the 0 up. So 8.21, and this is, most of these are milligrams, but just check that real quick. Okay.